Got it. Hello. Yeah, so good evening, everyone. Now we'll start our hands-on session, and it's good that many of you are familiar with Python, and most of you have Python running. Excuse me, those who haven't installed Python, there are two ways of going about it. You can work without having Python at all on your system. Okay, but for that you need internet connectivity and a Google account. Yeah, so what I'm talking about is the Google Collab. So just one moment on what Google Collab is, and then we will go into how to install uh, the Python and so on. Okay. So essentially, uh, you go to your Google prompt and look for Google Collab. Yeah, and it says welcome to Google Collab, and you have this Google Collab. Okay, and then it shows how to use Google Collab and so on, but there's nothing much to worry about it. So you go into Google Collab, just click that. Is it fine? Okay, so here we are in Google Collab, and you see open Collab. So, right? So if you already have an account and you have things lying in your drive, Google Drive, you will see whatever you have. Okay. And if you already have, say, see this IPyNB, this PY is for Python, NB is for Jupyter notebook. So these are Jupyter files, all Jupyter. So there are various ways of interacting with Python. Some people use Spider, some use just the Python prompt and do it. But Jupyter Notebook is one very convenient way. Is one very convenient way of doing it. So I'll repeat, Margarita. Should I repeat that? Yeah. Okay, so don't worry. So I'll close this. What I said was, yeah, they be logged in into your phone on. People who get unmuted by them by mistake. Yeah, so here. So is everyone with me? Google prompt here. And in this Google prompt, just go for Google Collab. So sorry for those who are already familiar with it, but let's take others along with it. And so just be a little bit patient. So yeah, Google Collab, and here is this Google Collab. Yeah. So if I click that, it takes me there, and you open Collab. Okay, so if you don't have anything in your directory, then you can say you can open a new notebook. There's a file, see file.
Actually, this year, top level, COVID just started. Salvo ya. Ahora no hace tener. Salva.
Thing is, you can use it as a basic calculator. And what you will notice, say if I say 35 plus 90, it gave us 125 right away. And if I say 234 to the power of 6778, and there it is. You know, in seconds it can do these calculations. And gone are the days where you had the limit on the kind of integers you use and the limit to the largest floating point number you could use in Fortran or on in C and so on. Here you don't have to declare variables and you can't, there's no limit to how big. Obviously, there's a limit, you can't have an infinitely large number, but these numbers can be extremely large. So when we do 234 to the power of 6678 or so, and in a flash it is doing it, right? And then this Google Collab will permit us to do whatever we need to. For example, we'll be sharing some files, open notebook, and suppose I open this. Yeah, so here's a notebook which is for AstroPy. AstroPy, there are various packages in Python. One is Numpy, Scipy, right? Numpy for numerical computation, Scipy, scientific ones, and so on. And there is this cubic root. Yeah, so there should be functions which are defined. Yeah, so I'll just show you. So one thing is by this Google Collab. Okay, yeah. Now let's take a small break and go back to, yeah. Let's leave this for a moment. So this Google Collab will
हेलो
be,
हाँ बोलो
yeah. So Google Collab is,
আচ্ছা আচ্ছা তো নিয়ে আসেন আর কি আমি 50 টাকা আপনার দিয়ে দিব আচ্ছা আপনার কাছে ঠিক আছে ঠিক আছে ঠিক আছে আপনি কি নিয়ে আসেননি
they have gotten. I have found it. Yeah. Okay, so but always it's a good idea to install Python and all on your system and all the packages which you generally use and run it. And to do that, again, we go back to our guru Google and you say installing Python on whatever system you want, say Linux, or you say Windows or Ubuntu, whichever you have, and it says how to install Python in Ubuntu 3.12 or whatever version you have, and it tells you what to do. Yeah, so it will 3 point something, 3.12 and all of the new ones. Go for Python 3 and above. 2 and all have become outdated and redundant. So take the latest one. The number indicates in the order of numerical one which goes up. You go for that. And in Linux, you do it this way. You say sudo, you start a terminal, and as the instructions show here, see, you start this terminal. Those who are using Linux, yeah. So by the way, Python can be used on any platform. You can have a Mac, you can have a Linux system or a Windows system, but the version which you install obviously has to be compatible with your operating system. So and the instructions are given all the time. See, for example, to open your terminal, press Control Alt T, yeah, and we know there are many ways of opening terminals. And then you run the command sudo apt update. So this is for Linux. Linux, that too in Ubuntu. If you are using Red Hat and all, then you don't have this sudo apt get one. But the Ubuntu family, for example, Mint and Debian, they all belong to the Debian family. And this sudo apt is a very powerful way of installing software on your system. So you sudo apt update, and once you run that with internet connectivity, it will ask you for your root password, your and then it's updating all packages, and then I have to run this command sudo apt install python 3. See that this will, Margarita, this will install your latest version of Python 3. So once it has updated, then you run this. So you'll have to install app then. Yeah. So yeah. So as you did you okay. Okay, so generally, acha, yours is not Ubuntu. So this is that's the thing. Yours is Red Hat based. Okay. No, no, no. So you just have to say installing Python on CentOS. Okay. And it will say you may have an RPM, Red Hat Package Manager is what you will be requiring. Yeah. So CentOS, how to check CentOS version, all this it says. Installing and configuring Python on CentOS 8. Or right. So see, we are living in a time when people are ready to uh, help each other. And for CentOS, you have this DNF update, like you had sudo apt update for Ubuntu and the whole family. Here you have this DNF update and then DNF install Python. Or if you are not logged in as a root, then you'll have to do sudo DNF install Python. Yours is CentOS or which one? OS 8? Okay, 5. No problem. You look for 5 there. Or as of now, you can do whatever we are doing in Google Collab, and then in the evening we'll install it for you. Okay, so don't worry. So the web is a very helpful place, and there are a lot of people who have similar problems like you have, like you are having no space. आपके पास Google account है, Google में ज्वाइन कीजिए, लॉग इन कीजिए और उसके बाद से रन कीजिए वो, ठीक है? अच्छा, those who are having a problem after the session, either give your laptops to us or I'll take it home and install it and get it, or else you with your password too. Okay. Yeah, so here it is. So suppose we have done it and everything is running fine. Yeah, sudo apt get install and we do it. And then to start Jupyter Notebook in Linux and similarly in Mac, you have to open a command prompt window, CMD window, and you type Jupyter. Jupyter is not, it is Jupyter. It is not Jupyter, Pitr, right? Because this py is Python basically. So we say Jupyter and notebook. And I would suggest put an ampersand before you press enter. Okay. So what does ampersand do? Ampersand makes your prompt available again for you in this window. You can start running something else if you want. Otherwise, the whole thing will hang till the time this terminal will be blocked till you finish your job and you start something else. Okay, so what has happened is when I ran that Jupyter notebook, it opens your default browser, whether it's Chrome or Internet Explorer or Safari or whatever it is, and it opens and it shows you the whole file structure. So you can navigate and go to a location where you want to work. Yeah, for example, I go to the desktop and I go to Mano Workshop 2023, which I've already created. There's a location there, and whatever I'm going to do will sit in this directory. Yeah. The other way of doing it is I open this notebook and I go to the location where uh, I go to the location where I have to cd is the name of the Manu workshop. Okay. So I go to cd Manu workshop, and from here I run the Jupyter notebook. This is a still better thing to do. You can create a location, know where it is. So through your terminal, go to that point and then invoke Jupyter notebook. Okay, and here I can start either I open one of these which I have here. Otherwise, I can start a new one here. Here, you can upload it or you can start a new one. And I'll oh God. Some more. नहीं, okay, okay. Yeah, ये भी आ गया अभी. The battery is not there. Okay, so I'm starting a new one and uh, Okay, so this is the Jupyter notebook, and something which we did in Collab, we do the same thing, and you will see that yeah. So you go back to your, since Jupyter Python is not installed in a system, you go to Google Collab and open a new notebook, and okay, so it right. So here we are, and now see, for example, addition, subtraction, division, multiplication, all are the same. It also has division, modular division. So suppose I do 34 modular division 5. So 5 goes into 34 6 times, and 4 is the remainder. So there are different divisions. One is the normal division, which gives you 6.7. If you say 34 slash slash and 5, you will get just what is it divisible by, right? So one is giving 34 slash forward slash 5 is giving you, actually the floating point number which you get. While if you use the percentage one, it gives you the remainder. And if you take 2 of these, you get 5, right? And similarly, you can check up all the math symbols which are available and you do it. So now suppose we get a little more mathematical and say I want to find out what is sine 45 is, right? And since Python is so smart, we expect it should give us the answer, but you have a problem. It doesn't know what this sine is, right? So what, there are 1 or 2 or 3 packages which understands these mathematical one. One is the package called math, right? So I say from math import sine. Okay. And now when I do sine of 45 or sine of whatever you want, it is going to give it because you have imported from the math library what sine is. And obviously, if I try to do what is cos of 78, it doesn't know because I've only imported one function which is sine, while math has a lot of things, right? So one crazy way of doing it is I can say from math import cost. So whatever you are using, you keep importing that particular one and doing it. Or you can once and for all from math import star. And if I import star, it will import all the functions which are there. Okay. So now if I try with cosecant 67, oh, it doesn't know. Cos is there and secant will be there and so on. Okay, so it has imported everything. But this is also not a very smart thing. This is not how people work in Python. Usually, what is done is something of this kind. I will open a new Python notebook, and now that I have opened a new one, it has forgotten what sine is. It doesn't know, right? So what is generally done is we say import math as I give one alias. I say import math as M or whatever, right? See, otherwise, I think even this should be fine. Math dot sign of this is yeah. So we'll first we'll have to do import math, and then once I've imported math, I can say math dot sign or cost or whatever, and it will do it, right? Math dot cost, math dot apps, math dot whatever, and obviously our Python is pretty good to handle variables. We can define A as 34, B is this, sorry, B is 56, and I can define a number C which is A plus Bj, not capital J but small j. Oops, sorry. C is 2 plus 3j. Yeah, so we can define complex numbers too. And suppose I have D which is 5 plus 9k. I can do C plus D does handles complex numbers. C, D, then real, C, not there. Right, absolute value of C and so on. You can handle it this way. So, yeah, so what we can do is generally what is done is import math as M, right? This is how you import it. And when we wrote math dot sign of 89, this could also be written as M dot sign of 89. Okay, so instead of writing math all the time, it becomes easier. Here, math was not a big name, but suppose it was AstroPy or something, then it becomes easier, like matplotlib as PLT. Okay, so this is the way we do it, and you can say import numpy as np, and this numpy also has a lot of mathematical functions, and even here I could have used np dot math, np dot cost of whatever, and this will also work. Like math had it, numpy also has it, scipy also has it. So there are various packages where many of these mathematical functions are defined. So numpy doesn't just have math functions, but it does many more things which we would be required to do. Okay, so this is the simpler part, and you have to just get used to dealing with these things. So I'll go to this, yeah. Yeah, going back to this Jupyter notebook, you notice that there is a window here which says code. And if you click it, sorry, code, or I can call it Markdown, right? I can change it to Markdown. Okay. Code is, yeah. when I'm running a command, say 34 into 78, then it should be the code, right? But I can create a markdown window and I can make notes. I can say introduction to arithmetical operation, right? And press enter. It comes as a text. It's a markdown one. And in this markdown, you can create, if I put a hash and a gap, it comes out as a big title. And in the next line, if I say put two hashes, it works as section, subsection, subsection, and so on. So here, introduction to, first I will say mathematical operation, and first section is arithmetic, right? And if I say I put three hashes and say addition, you see it comes as big, bold, smaller, and smaller. So you can create section, subsection. You can create bullets in it. You can, okay. So this can be used, this Jupyter notebook can be like your notebook which contains everything, the code, the instructions, the commands, the description, everything. You can insert graphs in it and so on and so forth. And in fact, you can also put the LaTeX command. For example, between $2, if I say alpha to the power of n plus slash, here the LaTeX command, beta to the power of n equal to slash gamma gamma. Gamma? Okay, yeah, okay. Sorry, yeah. And capital G will make it a big gamma, uh, and the small g will make it a small gamma. Okay, so you can get all these math equations and all those things. Okay, so this is a markdown one, and right, so you can create things here. Okay. See, for example, you can say introduction to Python. So we'll share this notebook with you. So this is basic introduction to Python. And we have these notes here. Programming and scientific research is important. Yeah, so why do we need to use Python to handle data? Is because once you are dealing with a lot of data, you need some kind of a computing tool to handle it. Secondly, if you want to do a certain thing repeatedly again and again, you can write a function or a macro and you can repeat it, right? So these are the reasons why we are using Python. You can do whatever we are going to do in this workshop, even in C or whichever language you like. But somehow Python is something more very convenient. For example, it has very good graphic capabilities which are not there in C. It's very cumbersome to do graphs, and even in Fortran you have a problem. And Python has been growing for a long time, and there are different communities who are working towards building different aspects of it. For example, there is one whole package which is AstroPy, and these are created for astronomical users, which can be used to download data right away from the cone search from whichever database, Hubble Space database, or from Gaia or whatever. We'll have a look at that. It will tell you how to handle FITS files, how to see the header information of a FITS file, how to stack up images, how to subtract images, all those things which had to be done with different software. There were different softwares used for different tasks. This is a one stop solution for everything, right? There was a time where people used IRA for optical data, yeah, image reduction and analysis facility, and for that you had to install DS9, deep space time DS9, to visualize data and to see the header information and various things. All that can be done right from Python. Secondly, there is an AstroPy, and in that there's a pie. We will have a look at it maybe tomorrow, or if I can rush through this, then I can go into the AstroPy today itself. Yeah, so what I would suggest is when we share this file, you go through this, and there is some general blah 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 which says that Python it's an interpreted higher level general purpose object oriented programming language, right? So many programming languages, you write the source code, compile it, and run the executable file. Here the code itself runs, right? So it's interpreter language, and it's a high level language because there are many things where it all understands. If you define a equal to square brackets 1 comma 2 comma 3 colon and so on, it becomes a matrix, and you can add matrices, and right. So there are mundane things which are very cumbersome when you are doing it in C, becomes much simpler here. So this also shows, this notebook also says how to install uh, Anaconda distribution. Anaconda is a good distribution which is, you can download it. In Linux, it downloads a .sh file. It's a shell script, and when you run the give it the execute permissions and run it, and it installs the whole thing. Okay, so so here it tells you how to install it. Okay, and getting started with this. So installation information and all is here. Okay, and we have seen these simple calculations. A is 2, B is this, C is what, and print C, right? These are very simple things which the beginner should try to run and see how it's working. And these are very obvious things, right? And then when you want your output to come out in a specific way, you can say A equal to 7, B is 3, and print sum in inverted commas and A plus B. So the output, as you see below it. So in Jupyter Notebook, you write the code there, you get the answers right there. If you have graphs and all, they come out. So somebody is asking what are the benefits of Anaconda. Anaconda is a very neat way of installing all the required packages which we generally use. It installs Python, it installs Jupyter Notebook, it installs various things which we generally use it. So it is otherwise you'll have to install everything one by one and so on. So these Anaconda is a very convenient way of installing uh, Python, right? So I would suggest others to do the same thing. So you have Anaconda installations for Windows, for Linux and for Mac as well, right? So this notebook shows you how to handle strings and labels and so on. And see, and then whenever you want to know, for example, you want to add another, you can always add another uh, block here, and you can say, for example, this is an important command type, and I say what is that. Oh, I should have run this and then run this. So it says it's a float. What type is it? Whether it's an integer, whether it's a float, whether it's a string, or so on. For example, if I'll add a few more rows here, and say, suppose I say G is equal to my name is okay, and when I check what is the type of variable G is, it says it's a string. Okay. Okay. So there are times when you are dealing with uh, tables, say in astronomy table. Sometimes when you download data, it downloads as astro table. Uh, there is another format which is called Pandas data frames, right? So you can convert from one to another and so on. And there are times when you have to know whether what kind of a variable we are dealing with. Okay, so this type commands tells you what it is. Similarly, if my K was say this one, and I say type J, it will show it is an integer, right? So unlike C, in C you have to declare a variable as a float or a integer or string or whatever. But here, when you on the fly, as you use a variable for a specific thing, it stores it in that category, and then you can also convert from one to another. Okay. So this Python notebook will show you these things. And then there are various functions in it. For example, I had a st was a string, and when I say st dot upper, it is converted into the into caps, right? This is a string. St was a string. If you notice here, let me add another. Let me add. Suppose I say um, name equal to Hasan, and then I say name dot upper, and it is converted into the uppercase, right? Okay. And when you press this tab a couple of times, it shows you all the possible options which is going with, which can go with that string. Say one is capitalized, one is case pulled, one is to center, one is to encode, and so on. So it will give you a list of things which are available for that function. Yeah. And join, like for example, if you have two strings, you can use this join to join with something else. Okay. So join, I say st. Yeah, there was one string called, you can Yeah, capitalize is converting the first one to capital N. So there are various such ones which are available. And similarly, you can add, concatenate two strings and, right? And here you can try these out. And yeah, the join, yeah, dot join balloon. So one was balloon, which was, Neha has a balloon. And so when you say this dot join balloon, it has joined the whole thing there. Similarly, you can reverse, you can, there are various functions where you can write it in the reverse order and so on. These are the things which we shall not be using in astronomy, but this will show you basically how to append if you have a list. Yeah, so we have seen what are integers which are floats. Similarly, you can define a list. You can have a series of numbers which can be defined, and you can append things to the list or delete or and so on. So this Python notebook, you'll be able to see various things, simple things which are possible, and how to convert data types from float to integer, integer to float, right? So when you say 390.8 is a floating point number, but when I say int that, I convert it to integer, right? So it is, okay, so one, for example, I'll store this as a equal to this, and then I will just put a, and when you see what a has become, it has truncated the decimal part. It has just made it 390.8. So these things, once in a while, they are required. We require to do it. How you round it up, how to truncate it, how to get the remainder. Yeah, you modular value or so. Okay, so you can convert from certain data types to another. In sometimes it doesn't make sense. For example, if I have the string called Hasan and I can't make it an integer, it doesn't make sense. But a number I can make it if it is say 25, I can convert it to a string, but then it doesn't function as a number. It will work as a string 2 and 4, 2 and 5. Okay. So then there are these very obvious conditional operations which will be requiring. If x is such and such, right? If x is less than 10, semicolon, then y should be equal to x, else y should be 2 and print y, right? So if else statements can be done, and you just have to learn that the structure is if, and x is, whatever the condition is, then you have a colon there. And then you have, in this case, you have only one statement, but you can have a host of things here. Y equal to x and x equal to 2 plus 7, 5 or whatever. You can have a list of things which it does. And if x is not less than 10, then it will take y is 2 and do it, right? So you can have various conditions and do various things along with this. And remember that if we run this with y equal to x as aligned with f, if it will not work, it has to be, there has to be a tab here. Similarly, all the conditions will go with else, all have to be, they have to be uh, shifted by a tab. Okay. So, yeah, so look at these. Then there are these loops which are also obvious to use and important. For I in range 3 to 13, print I into I into I into I, right? So it is giving you from, right? First it starts with 3, then It goes on till it reaches 13 and it is stopped, right? So similarly, we have these kind of loops and so on. Okay. This is something on uh, defining functions and yeah. So coming to this Numpy is a very basic fundamental package which is used for scientific computing with Python. And we look at this NumPy array. Say, for example, I say A is equal to, right? So what we had seen earlier, we have to say import NumPy as NP. This is, you needn't call it NP, you can call it whatever you wish. But it has become a standard that people import NumPy as NP. It has become, right? But you have a choice to call it XYZ, right? But whenever, whatever alias you are giving, you have to use that XYZ dot something to invoke all the functions which are in NumPy. So this is, yeah, and what we have seen is to run each block. There are two ways of doing it. Mark that block and either use this run command to run it, or you mark the block and shift enter. Then it gets executed. Okay. So I have executed import numpy np from Scipy import stats, import matplotlib.pyplot as plt. See now there is this matplotlib in a pack in pyplot. So to be writing matplotlib.pyplot.sign whatever it becomes x comma y, it becomes very cumbersome. So this whole line matplotlib.pyplot, we'll just call it plt and import cborn as SNS. See, cborn is matplotlib is a way of plotting data. It's a very easy way of making plots. Uh, Plots, histograms, pie plots, uh, various ones. And Seaborn is again for plotting, and it gives you even better plots and graphics. Seaborn, right? So we'll be roughly covering both these things tomorrow also. But Seaborn is used very often to make very beautiful plots. So I've run this thing, and so now that it knows what NPy is, I'm declaring, I'm saying A is equals to np dot array 1, 2, 3, print A, print type A, print A shape, and print A0, print A, yeah. So let me run this, or let me first comment all this. Commenting is control and /. If you mark all those, just control and this, it gets commented. And see, I have defined A as NP array 1 to 3, and when I'm printing A, it is giving me what it is 1, 2, and 3. Okay. 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 Yes, I'll add some. Import numpy as np. Okay. Right. Now I define say A equal to np dot array and np dot array, and I'm giving the values whether you want a one-dimensional array or two-dimensional array or so. So NP array, this is a function. So you have round bracket, and in this I am defining this array, say 2, 5, 7. Okay. And so now when I find out what A is, it is this array, right? And if I say print A, yeah, A is 257, right? Similarly, I could have defined another array B, which is a Numpy array, which is say 1, 4, 8, and 6, 8. It should be square bracket. Just some mistake. Yeah, so this is an array with, yeah. So there was one square bracket missing. So array is a function. So you have two round brackets, and that array which I am making is an array of, yeah, right? 1, 4, 8 and 6, 8, 9. Okay, so I can make, for example, in you have sets of sets, right? Now, if I look at, if I say print, I look at print and check what B is. Yeah, this is the array, the two-dimensional array which we have defined, right? Similarly, I could have defined it as a three-dimensional array, which was say 67, 78, 89. Okay, and now when I say print B, it is first is 148, 689, and 786. Okay. So now if I look at the shape of shape, yeah, this is the shape is, it has 3 in it. If we look at for B, yeah, they are 3 by 3, right? So it's a 2. So there are various ways you can. Now, if I define NP zeros 2, 3, it will make 2 rows, 3 columns, things with all zeros entered into this. Okay. So you can use this file to do it. And now suppose I define something called x equal to 2, 3, 4, 5, 7, 78, 89. right? And right, and then I look at numpy dot mean of this x. It will give you the mean of. Okay. Similarly, you can say np dot max of x, right? So in this, it is giving you what the maximum one is, and obviously you can try min of it. It will give you the smallest number in that, and so on, right? So np dot mean, np dot numpy has lot of functions which are defined there. Similarly, we have seen numpy also had sine, cosine, and so on. Similarly, numpy has certain uh, uh, certain constants. For example, pi, the pi. So np.pi is the pi of, yes, so in the circumference of a circle, the pi which we have. So some of these constants are there, and you can use them. Similarly, you can generate random numbers, an array of random numbers, and so on, and do various mathematical operations with these arrays. And okay, so I will share this. These errors are showing because we have to run one by one to do it. Yeah, NP is not defined, it says, because yeah, so if we run it again, yeah, so all fine. Yeah, so it's 5 o'clock, and you are following what's happening, right? How many are having problems? Is how many are stuck? Don't be embarrassed. Don't be shy. Initially, it's a problem, but once you start doing it, you become more and more confident, and you get the hang of it, right? So basically, it's not difficult to learn, and okay. So okay, so now we have time till 5:30. We have another half an hour. So if there's some issue which you are having, which we can go around and check it out, or those who are familiar with this already can do it, right? Yes. Yeah, we'll share this file. Yes, we'll give you the link, and okay. So this is a we have collected some basic things which are required for people to know. Those who already know can skip this and go ahead. Okay. Now for those who have not, you are familiar with all this, let's go a little beyond so that you can do uh, something at home today, and we'll share you. Yeah, so so this is on AstroPy. So see, one thing, the one way of learning any programming language is you start using it. You should get some basic hang of it, get the basic structure sense, and learn what are the basic keywords and operators, and how do you define a function, how do you define loops, how do you define if-then statements. Each programming language has its own nuances, right? For example, in Fortran, the good old days when we were using Fortran, you had to write the program between the 7th and the 72 column. Anything behind the 72 column onwards, it would not read. First to sixth, first to fifth were, first column was reserved for commenting. If you put a C or percentage mark, it used to comment the whole line. Second to fifth was used for statement numbers. And Fortran had programmers in Python, in Fortran, they would say, do this, do statement number 30 till something happens, right? Statement numbers were used a lot and loops were created using that. Slowly that vanished. And if you wrote anything before the seventh column, you would get an error, you would get a problem. Sixth column was used to show continuation, right? So there were certain nuances which you had to learn. Similarly, C, you have to end everything with a semicolon. Every statement ends with a semicolon, right? Any variable you are using, you have to declare it before you do it. You have to say int A, B, C, and then you start off. If you have not defined a variable, you couldn't use it. Python has become much more flexible. It doesn't care about the length of your line, uh, but in certain places it does care. Like for say, if a condition is true, then do this, and all this have to be tab separated, right? And in fact, when you are typing it, automatically your cursor goes somewhere else, and that's where you should start typing. And then when you go to else, you start from the first row, and then everything gets intended, right? So there are small nuances which you have to know, and you build over that. Python has this interesting feature where you keep seeing this. Import matplotlib as something, import numpy as something, import astropy, import units as whatever, right? So now this astropy, we'll share this with you too. And astropy is a package for astronomy in Python. It handles units which are used in astronomy. For example, you can define something called a light year, a parsec, then coordinates. You have right ascension, declination. You have right azimuth. You have galactic longitude, latitude. Right. All these coordinates, things become much more simpler because the moment you define something as a light year, then the unit for that whole area, that variable is a light year. Okay. And it knows light year is what in terms of meters or in kilometers or in whatever, right? It's a measure of distance. So this AstroPy is a single core package for astronomy in Python, which handles units, it handles coordinates, it handles it handles fixed files, it handles tables, and it helps you search the archives through this. And there are various resources which are listed here. And if you go to any of these, you click on any of these AstroPy workshops, AstroPy tutorial. So once we share it with you, you'll see that once you click it, it takes you to that location, and there are many things which are available there. Yeah, it has taken you to a GitHub page where these AstroPy tutorials are there. Okay. So So this is the first one, and you have to, you'll be requiring this matplotlib for plotting things and so on. Okay, so import matplotlib.pyplot as plt, shift enter, and then and then you import Numpy, which we have already seen, and we import AstroPy, right? This is the AstroPy. And if you want to check the versions what are running on your system, you run this command, and the Numpy which is installed here is 1.20.1 and AstroPy is 5.2.2. Okay. So this is sometimes important because certain commands, if it's giving you an error, then you can search on the net and say that I'm getting this error in AstroPy 5.2.2. So they'd say that this command has been replaced by something else. Okay. So print numpy np dot this version dash dash version dash dash. It will give you the version of numpy, and similarly for scipy and whatnot. Okay. Okay. So then from AstroPy we import units. There is a package called astropy.units which handles the physical quantities with units. Okay. So from AstroPy import units as you just run this command, import AstroPy. If you are getting an error, if AstroPy is not installed in your system, then you will get an error there. And for that, what you need to do is in this you'll have to run pip install AstroPy. Okay, pip. Now if you get an error with pip, then you'll have to install pip. So conda install pip. And if conda is giving you problem, then you'll have to install conda, and right. So generally, if you have installed Anaconda, then these things will work fine. Right. So pip install is something very important which you keep using it. So in fact, when you say import numpy as np, it says it doesn't know what numpy is. So there you just have to create one cell like this and say pip install numpy. Okay, pip install scipy, pip install. So once you run that, if you are connected to the net, then it will check your system, and it says already satisfies AstroPy is wherever it's sitting there. Yeah, site package this, requirements already satisfy, everything is fine. And if it is not there, then you will have to run that. Okay. Same thing in Collab, right? So when you start a new notebook in Collab and you say run commands from AstroPy, it may not know. So you will have to say pip install AstroPy. So then it installs it for that session. Things work fine. You log out, go home and start using. You may not find it, so you can again reinstall it and right AstroPy, because okay, so here is this AstroPy, and it says note you may need to restart kernel to use the updated package. So whenever some package has been installed for the first time, then you have to run this, restart the kernel. Yeah. So when you restart, the all the cells which you had run earlier, it will forget, right? So you'll have to start running things again. So the kernel has been restarted. So whenever you install a certain thing, you have to restart it. It warns you, tells you it has to be restarted. So there are two ways of restarting the kernel. One is a stupid way where you come out of that notebook and go back in, or just restart it from here. That this mark which you see here. Okay, so and to execute like we have seen, we run. Yeah. So now that I've already done this, I don't need it. So I will just put a hash here. Okay. Now that AstroPy has been installed, so from AstroPy, we are importing units as U, right? The same thing something similar which we have done from math import sign from math, right? So here from AstroPy import units as U, okay? And the reason why we are using units as U is below, see for example, distance 1 into U.AU. So I'm just writing U.AU and it notes it is in astronomical units. Okay. Otherwise, you would have had to write UNITS.AU. UNITS dot light year. Okay. So there are all these which are there. So okay. So the variable distance 1, I'm calling it, I'm having it in astronomical units. That is 150 million kilometers, right? That's the distance between Sun and Earth. And when I'm printing what this distance is, it is telling me it is 1 AU. And obviously you can convert this into, now if I'll add another, yeah, so my variable is distance 1 dot 2, and in brackets I say in meter, it is telling me what it is in meters, isn't it? 1.49596768 into 10 to the power of 11 meters. If you want to convert this to kilometers, distance, say, see, distance is the variable name, dot 2 is the function, and we are converting into kilometers. So you can convert parsecs to AU to parsecs, megaparsecs, all those things, light years, right? So similarly, we have unit AU, we have unit called light year, right? We can convert it to centimeters, we can convert it to parsec. There is another called U.parsec, right? Parsec. To convert to parsec. U.parsec, yeah, U.parsec. U is because we have units, we are calling it U, right? So instead of writing units dot parsec, we are calling it U.parsec. So now I am defining a variable, say this distance is equal to 1 into U.parsec. So this is distance is a 1 parsec, and when I am converting distance to in meters, it is showing me 1 parsec has how many meters in it. Okay. And the other way of doing it is distance to U.meters, right? One is in semicolon, I was saying, in the string I am writing, in quotes I was writing meters. Here I am saying distance to meters, distance to light years, distance to whatever. Okay. See, for example, here, distance to light years. So 1 parsec, the distance was 1 parsec, and we are converting it to light years, which is 3.26156838 light years. Okay. So this makes it very convenient for you to go from one unit to another and so on and so forth, right? So once you realize that this is how it is, you can see what are the various options. For example, I'll add a thing here, and I say dot and tab. If you use, it has various options here. Capital A, small a, double A, this, that, arc minute, arc second, AU, and what are these AB amperes and so on and so forth. So some of it we don't know what they are, but you can always search the whole. These are with all the A's, then it will go into all the B's, it will go into all the. So for example, I want in part 6, the moment I said P, it has given me PA, parallax, arc minute, parsec, right? Pascal. So there are all these possible units which are there. And if you want to find out what is peta Gauss with capital G and peta Gauss with small g, just Google search in Astro what they are and you'll find out, right? So it has all these different units which are there. Okay, picoamperes and so on and so forth. Okay, so right. So how do you do it? U dot or np dot tab. And sometimes this tab doesn't work. If it doesn't work, then Google search. My tab is not doing it, and it says that do this, and it will get done, right? So what we are trying to basically doing in this workshop is instead of giving you the fish which you can fry and eat, we are teaching you how to, catch it yourself, right? Yeah. And what are the options? Basically saying that these things are available, and this is how you can get. So you Google search for anything, you say for apps. Obviously, NP ABS should be giving you absolute value of something, right? So many of the things which you already know, but right, for example, Numpy abs itself tells you the absolute value, and I have taken 2 plus 6j complex number, and it has taken 2 square plus 6 square under root of it and given the value, absolute value, right? So yeah, so this tab and tab doesn't work, don't panic. There is a solution to that. I can if somebody is having a problem, tell me and we can fix it up. Okay, so using these units, you can do various things, like you can find out what is the speed of light. Distance was 1 parsec. What is distance? It was parsec. What was distance? 1 light year. Okay. So last time you define a variable, and so yeah, 1 light year. Okay. Now 1 light year by unit here. And when I'm converting it to kilometers per second, it is giving me this is the speed of light in kilometers per second. You can do the same thing in meters per seconds or whatever. So you can call this centimeter slash second and it will convert to that and so on. Okay. And speed of light, angstrom per day, right? So you can have all these conversions, and you can do that not only for a single value or single variable, but you can have an array. For example, I am now defining distances as 1, 6, and 10, and I am giving it units light years. So when I say distances, I mean 1 light year, 6 light years, and 10 light years, right? We are defining one whole array of distances, and then you can use it for whatever conversions or use. So if you're doing some computation and you are finding it for different redshifts or different, yeah, you can define it. Okay. So this is what the unit does. So we'll share this with you too, and just go through it, and you will see that how these things work. Right? Right? It's very simple. And yeah. Okay. So we have 5 more minutes. Basically, yeah. Now, one more aspect of this AstroPy is handle coordinates. Okay, so in coordinates, we have to import, like in units, we imported units. Here there is a class called sky coordinates, right? And be careful that Python is case sensitive. When sky is with a capital S and C is with capital C, you have to write it that way, right? So from AstroPy coordinates, import sky coordinates, and I am defining, say, for example, position of crabs, right? This is the Crab Nebula, and I am saying 83.663 in degrees, and this is RA and DEC in degrees, both of them in degrees. You can also have it in hours and minutes. Okay. So, right, so this is, so one way is we are specifying the sky coordinates are these which we have maybe found, we already know what it is, but you can actually search these sky coordinates right from, yeah, so see, for example, here I'm giving in terms of minutes, hours, hours, 5 hours, 3 minutes, 2 minutes, seconds, and degrees. Okay. So you can write it in terms of hours, minutes, seconds, or you can do it in degrees, either of it. Okay. But you specify, and what frame we are using. ICRS frame is the International Celestial Reference System. Yeah, the RADEC. Okay. Interestingly, I can get those coordinates even this way. Sky coordinates dot from underscore name, and I specify the name of the object, and it finds out what the sky coordinates are. For example, say for M13, when I run this command, right, and when I check what it is giving me, it is 250.42 RA and 36.48, right? Both are in degrees, which you can convert it to hour and minute, right? So sky coordinates dot from name will hunt out that and do it, right? So it's pretty good. Similarly, you can get it from, you can convert. Yeah. That from the basically NGC 2345 and all you say it should get this catalog. Yeah. Yeah. Maybe. the coordinate name. From this database. So, the same database, right? So, Simba one. So, right? So M31 size 4. These are the ones. The same thing I could have got it from there by typing by name. Yeah, Simba name. Simba name. Simba catalog. Okay. So okay, so yeah, so basically I think 5:30, you all must be tired. So we'll share both these Jupyter notebooks and you run them and no, this is another notebook. There's so many things open here that I have to open it. Okay, so I think we should stop for today. Yeah, so and if those who are having problem, they can contact us. And yeah, let's stop for today. So this AstroPy, we'll see more of AstroPy tomorrow. You can see, you can get these coordinates, you can convert them to galactic system from, yeah. So one thing you can do is, you can go to GitHub with my, and I'll send you the link. Okay, I'll share you with my, actually with my, hasan.najam@gmail.com. So we'll share the link with you. Yeah, so there is a folder called Ayuka Workshop, Manu Workshop. In that you have all the files, and you can download the Jupyter notebook and run it. I will share the link on or the Jupyter notebooks we can share. Okay, so let's stop for today. Yeah. How many are unable to follow? Just raise your hand. Everybody is following.